Hello everyone, welcome to the world of fiber optics communication. Today we will discuss basics of fiber optics communication. After today's lecture, you will be able to compare different optical fibers and their applications. Also, you will be able to relate numerical aperture and acceptance angle of a fiber. Now, optical communication is not new to us. Probably it started with the invention of fire. But with the advancement of electronic science and invention of laser and other optical communication related components, nowadays we are connected across the oceans through fiber. This picture has been taken from Google Maps and telegeography. Now, what is the difference between fiber optic communication system and general optical communication system? They are almost same, but the optical communication system has two sections, electrical section and optical section. Electrical section is similar to that of the general communication system. Output of the electrical section is used to modulate the output of optical source like LED, laser, etc. Output of optical source is obviously light, and that will pass through optical fibers. And at the receiving end, it is collected through optical detectors. Output of optical detector is nothing but electrical signal, and that is fed to the electrical section of the receiver end, which is again similar to that of the general communication system. Now, why should we go for optical communication system? What are the advantages? Numerous advantages are there. To name few, first of all, extremely wide bandwidth of fiber optic communication. It is greater than 100 gigahertz, whereas bandwidth of millimeter wave and coaxial cable communication system lies in the order of megahertz. Using fiber optic communication at a time, we can send about 500 video channels simultaneously. Second is, in optical fiber communication system, as data transmitted through fiber following total internal reflection, the loss is very low. Third point is immunity to interference and crosstalk. And fourth point is electrical isolation. Now, generally, the optical fiber is made up of glass or polymer. These are free from electromagnetic interference, as well as it is free from radio interference. And if we put two fibers side by side, optical interference is negligible. Hence, this fiber communication system can be used in electrically hazardous surroundings, and also it can be used for less crosstalk. Then, high signal security. It is very difficult to tap the signal passing through the fiber optic system. It is not impossible, but require a huge components which is costly. Then it is small in size. Its size is almost like hair. Low power consumption is there. It is very rugged and can be bent over a very narrow angle. It is low cost, though the initial installation charge may be more, but in long run, it is cost effective. Let us consider the structure of the fiber. It has got two main portions. A very narrow cylindrical portion called core with refractive index N1, surrounded by another cylindrical portion called cladding having refractive index N2, where N1 is slightly greater than N2. Now, as the structure is very narrow, almost like a hair, To protect it from surroundings, different other layers are added, like buffer jacket to protect it from external mechanical influence, Kevlar jacket to increase tensile strength, polyurethane coating for protection from moisture, etc., etc. Now, how ray propagates through fiber? We know that when a light ray falls at the interface of denser medium to rarer medium, it moves away from the normal. And if it is greater than a particular angle known as critical angle, it will reflect it back to the first medium. And this is known as total internal reflection. Ray through light propagates following this total internal reflection. Now, there are two types of ray: meridional ray that will cross the axis of the core, as we can see here. Another one is skew ray that will never cross the axis of the core. It will follow helical path and it will be reflected from the surface of the core. So it will follow a path like this. Now, different types of fibers are there. We can divide it on the basis of material, on the basis of transmission, mode of transmission, on the basis of refractive index profile. Now, types based on material can be of three types: plastic core with plastic cladding, plastic core with glass cladding, glass core with glass cladding. You can see their structure, advantages, and applications. Now, based on mode of transmission, it can be single mode fiber or multi-mode fiber. For single mode fiber, only one mode will pass through the core, probably along the axis. Hence, the diameter of the core is very narrow. For the multi-mode fiber, more than one mode will pass through the core. Hence, the diameter of the core is more than that of the single mode fiber. You can see their diameter and applications. Now, based on refractive index profile, it can be either step index fiber or graded index fiber. For step index fiber, the refractive index across the core will remain same, and that is N1. And across the cladding, it will remain again same, and that is N2, where N2 is slightly less than N1. So, the refractive index will follow a straight-like profile. For graded index fiber, the refractive index along cladding will remain same equal to N2, but the refractive index profile within core will vary from the axis to the interface of core cladding, and that profile may be parabolic or triangular, as I have shown here. So in this case, it will not be a step, and you can see their diameter and applications. Now we will discuss two properties of fibers: acceptance angle and numerical aperture. Now, what is acceptance angle? Acceptance angle can be defined as the maximum angle at which light will enter the core to be propagated through the fiber. Okay. If any ray falls at an angle greater than this maximum angle called acceptance angle, the angle of incidence at core cladding interface will be less than critical angle, and no total internal reflection will be there. That ray will be refracted in the cladding part, and after few reflection from cladding part, it will be lost. It will never return back to the core. Hence, this maximum angle is known as acceptance angle. And if we consider it along 3D, then it will be acceptance cone. Now, what is numerical aperture? Numerical aperture can be defined as the light collecting ability of the fiber. Now, what is the relationship between refractive index, numerical aperture, and acceptance angle? Now, from this figure, we can say using Snell's law, n0 sine theta 1 is equal to n1 sine theta 2. Now, considering right angle triangle ABC, we can say that phi is equal to pi by 2 minus theta 2. Hence, n0 sine theta 1 can be written as equal to n1 sine pi by 2 minus phi, putting the value of theta 2 from this equation. Hence, it is n1 cos phi. Actually, this requires a little bit knowledge of trigonometry from 10th standard. Then n1 is equal to 1 minus sine square phi to the power half. Now, for limiting condition, this phi will be equal to critical angle phi c, and this theta 1 will be equal to acceptance angle theta a. Hence, we can write n0 sine theta a is equal to n1 1 minus sine square phi c to the power half. Now, from Snell's law, sine phi c is equal to n2 by n1. Hence, we can write n0 sine theta a is equal to n1 square minus n2 square to the power half. Now, generally fiber is used in air. That means n0 equal to 1. So, we can write sine theta a is equal to n1 square minus n2 square to the power half. That is our numerical aperture. So, numerical aperture can be defined mathematically as the sine of acceptance angle. So, after this, you will be able to discuss the applications of different fibers. I have calculated the relationship between numerical aperture and acceptance angle for meridional ray. You can try the expression, the relation for skew ray also, and also you can explore applications of different fibers for different applications, maybe in communication or maybe in other type. So, thank you.